OK. Final example, ladies and gentlemen. If you guys remember when we went over this, now I'm going to do the factoring a little bit quickly. But if you guys remember, the first thing, whenever we're dealing with rational expressions, anytime we're dealing with rational expressions, the first thing we always want to do is simplify. Before we find the LCM, simplify. So we look over here on the right. There's nothing really I can simplify, correct? OK, something really I can simplify over here. So I'm just going to leave that. However, over here I have two trinomials. So I need to make sure I know how to multiply them. So fortunately, a is equal to 1. So I have -3 and I have 1. And I say, you know, what two numbers multiply to give me -3, add to give me 1? Anybody? Anybody? 1 is the coefficient of x. Can that be simplified? No. So I can't simplify it. So that's cool. So if we can't simplify it, then we just leave it there. Now let's do the next one.
Wait, what?
-3 and 1. I'm trying to simplify this.
I know.
You can't simplify, you can't factor it.
Are you sure?
Well, what two numbers multiply to give you -3? It's either -3 times 1 or +3 times -1. Do either of those add up to give you 1? No. So it's what we call non-factorable. OK? So now, so what that means, ladies and gentlemen, is we just can't factor. But you always want to look into factoring everything. You always want to look into factoring. Now, so we do the next one. I have 32, and I have 32 and -12x. Or -12, I'm sorry, x. Where the heck did that come from? So now I want to determine, is there any two numbers that multiply to give me +32, but then add to give me a -12? -8 and -4. So I rewrite this as x squared plus x minus 3 over x minus 8 times x minus 4 plus 3x over x minus 8. Does everybody see what I did? Now we go through our first step and we say, all right, the LCM is going to be basically our, it's not, we don't have to multiply these because you can see they both share an x minus 8. So the only thing left they need to share is the x minus 8 times x minus 4. So now, to rewrite these so we can add them, I'm basically just going to multiply by x minus 4 in the numerator and the denominator. OK? So we apply distributive property here. So I have x squared plus x minus 3 all over x minus 8 times x minus 4 plus 3x times x is 3x squared. 3x times -4 is a -12x all over x minus 8 times x minus 4. And then what I want you guys to see here again is, do you guys see that we have common denominators? So now we just add our numerators. Well, we have some like terms here, right? We have x squared and 3x squared. We have x and -12x. I don't have anything to add to my constant -3, so that's just going to remain there. So my final answer is going to be 4x squared minus 11x minus 3 all over x minus 8 times x minus 4, where x cannot equal 8 and x cannot equal 4.
Wait, how do you get 4x squared?
X squared plus 3x squared.
So you don't add up the number 2? Like,
Huh?
You don't add up the exponent? No,
No, only when you multiply will we add the powers. Cool? All right, so you